We have two more subtopics that we need to cover before we finally wrap up this topic too. Okay. So in previous lecture, we have discussed about ionization energy, okay, and then the factors that affect the ionization energy. So we have to discuss in terms of across the period and also down the group. Okay, so across the period, you should be highlighting the Z effective. When you go down the group, okay, you should be highlighting the shielding effect, the increase in N and also the shielding effect. Okay, and then don't forget the anomalies, guys. Okay, the irregularities for ionization energy. So we have two anomalies for group 2 and group 13. Okay, and then for group 15 and group 16. Okay, so basically it's for group 2 dengan group 15 lah. Okay, it's due to the stability of the orbital. So group 2 has a full filled orbital which is already stable, and as for group 15, it has they have the half filled orbital which also stable. Okay, all right. So please take note on that, and then we have next subtopic, which is the electron affinity, EA, and the electronegativity. Okay, so just to remind you, make sure that you complete all the checkpoints. Okay, because we have already covered the ionization energy. Okay, all right. There are two learning objectives for EA, so this is not as many as what we have for ionization energy previously. Okay, so we have two learning objectives. Make sure that you are able to define electron affinity and then explain the trend in electron affinity of group 2, 15, and 18. Okay, so this is also anomalies 2, 15, and 18. Explain the trend of electronegativity across a period and down the group in the periodic table. So this is for electron affinity. Basically for electron affinity, we have one learning objective, and then another learning objective come from electronegativity. Okay, so the one that is critical is the ionization energy, because we have 5 for only one subtopic. Okay, all right. Moving on, what is electron affinity? Or in short, EA. So we are going to cover the electron affinity first, okay, based on this red colored font. So EA is the energy change or delta H, energy change, okay? This is not the same as what we have for ionization energy. Ionization energy, remember, it is the energy itself, the energy required to remove 1 mole of electron from 1 mole of atom in gaseous state and whatnot, okay? But for EA is the energy change, the perubahan tenaga, okay, that occurs when 1 mole of electron is accepted by 1 mole of atom in its gaseous state to form an anion. But before that, electron affinity, in short, is the preference towards electron. Kesukaan terhadap electron. Electron is electron. Affinity means kesukaan, preference. Okay, dia suka terhadap electron. Maksudnya the energy change when 1 mole of electron is accepted. Okay, this is opposite to ionization energy. For ionization energy, okay, it needs to be removed, but EA, it needs to be accepted into the atom, and it must be in gaseous state, okay, to form an ion. But for ionization energy, okay, the product will be the cation. For EA, the product will be the anion. Okay, and then it should be energy change. Okay, please do not get confused. It's not energy, it's the energy change. Okay, all right. So how do we write the the chemical equation for EA? Okay, so we have the atom in gas state plus electron becoming X minus. So this is the anion, and it should also be in gas state. Okay, so this is what we call electron affinity. First electron affinity, and we may have several following electron affinity. So we may have second electron affinity, third, fourth, and so on. So this is similar with ionization energy. Okay, so for ionization energy, we also have first ionization energy, second IE, third IE, fourth IE, and so on. Okay, all right, so please take note on this. So this is electron affinity. As you can see, it also a stepwise process. So meaning that the electron need to be added one by one. Okay, it cannot be added for example 2 at once ataupun 3 at once, tak boleh macam tu. Okay, it should be added one at a time. Okay, the more energy being released, that means it become more negative. Okay, release means the sign should be negative. Release means negative. Kalau more energy is released, that means it become more negative. The value become more negative. Okay, the larger the electron affinity. Okay, the larger the electron affinity. Right? Okay, so for example, so this is several elements that we can use for our example to represent the difference in electron affinity. Okay, so we have fluorine from group 17, lithium from group what do we call group 1, sodium also come from group 1, but at period number 3, neon come from group 18. Okay, as you can see, fluorine accepts electron becoming F minus. Okay, lithium accepts electron becoming lithium minus. Sodium accepts electron becoming sodium minus, and even neon accepts electron to become neon minus. Okay, all right. We want to study ataupun we want to check on the affinity of these elements towards electron. Dia suka tak the electron? Okay, so we can check the value of the delta H ataupun the EA itself. As you can see, the fluorine accepts it. When fluorine accepts electron, it releases this amount of energy. Maksudnya banyak dia release. Okay, remember, it's all about energy change. Energy change maksudnya ada perubahan asal kepada perubahan final. Okay, awal dan akhir. Kalau tak, macam mana nak dapat delta? Okay, alright, it's because of, imagine let's say we have fluorine kan. Fluorine atom is unstable. In order to become stable, it need to accept electron. Okay, kenapa dia nak jadi stable? Because everybody wants to become like noble gas. Kenapa nak become noble gas? Because they have a stable electronic configuration. Okay, that's why there are two ways in order to do that. It's either you accept electron ataupun you remove electron. Okay, in order to become like noble gas. Okay, so the reason why fluorine release more energy compared to lithium, sodium, neon, because initially, okay, kenapa dia release energy? Initially, the fluorine atom itself has higher energy. When it accept electron, okay, when the fluorine atom accept electron, so the energy become lower. So they become F minus. So this is the energy of the F minus now. So from here to here, nak jadi daripada atas ni ke bawah ni, okay, it release the energy. Okay, how much energy has been released? So this is the energy. The energy has been, the amount of energy being released. Negative simply means it release. Okay, the energy has been released. Okay, maksudnya fluorine favors to accept electron in order to become like noble gas. Yelah, fluorine group 17 requires only one electron in order to become like noble gas. Instead of accepting electron, instead of removing all the 7 valence electron, why not accept electron? Betul tak? Okay, maksudnya kalau nak buang electron, if you remove electron, so it would be harder because to remove electron, you need energy from outside. Okay, energy need to be supplied in order to force the electron out from the atom. Okay, so instead of doing that, just accept one more electron and then you will become the fluorine will become like noble gas. Okay, so that explains why fluorine has higher EA compared to lithium. We know that lithium do not favor, okay, lithium does not favor to accept electron, right? But still we can force it to happen. Okay, dia boleh accept electron becoming lithium minus. Okay, so the delta H is negative 61. As you can see, okay, perbezaan dia sangat tinggi the one compared to fluorine. Same goes to sodium. Sodium, if accepts electron, it becomes sodium minus, but the energy change is not that much. Okay? It is negative 54. As for neon, we know that neon is already stable, kan? So if we force it to accept the electron, yes, boleh, it is possible, it will become neon minus. But this process is not as simple as the others. Nampak tak the value here? The value shows that it absorbs energy. Okay, requires energy. So maksudnya neon tu initially dah stable. When it accept electron to become neon minus, the energy become higher. Okay, daripada sini jadi ke sini. Maksudnya from here, okay, to go from here to here, it requires energy. Okay, it requires energy. That's why they absorb energy. Okay, all right. Hope you guys understand what does it mean by energy change. Okay, that is why across the period, okay, saya bagi tahu awal across the period, the EA increases. Kenapa? It's the same reason as what we have learned earlier. It's because of the Z effective. Okay, dia block P tu, they favor the electron more compared to block S. Kenapa? Because of the Z effective. The Z effective is powerful enough. Okay, across the period, Z effective increases, kan? Betul tak? So the Z effective is powerful enough. Not only it can attract the electron in the atom itself. Okay, it is able to accept the electron from outside. Okay, dia berkebolehan untuk tarik elektron masuk ke dalam atom ataupun ke dalam sistem elektron itu sendiri. Okay, alright. So this is the first electron affinity for all these elements. How do we know so? Because they start from the atom itself. We may have second, third, and so on. So maksudnya dia sama macam the ionization energy. Okay, alright. Okay, for multiple charge and ions, the electrons are added stepwise with different electron affinity for each step. So different electron affinity may have different values. Okay, dia tak semestinya sama. Okay, alright. So let's look at the formation of an oxide ion from an oxygen atom. Okay, so this is the first EA, the first electron affinity. Okay, because it starts from the atom itself. It accepts electron and becoming O minus. Okay, like I said, it is a stepwise process. Okay, stepwise process, meaning that the electron need to be added one at a time. Okay, so O in gas state plus electron becoming O minus also in gas state. So this is the amount of energy release. Okay, the amount of energy release. All right, and then when we try to add electron further from this O minus, okay, this is what we call second electron affinity. Okay, so O minus in gas state accepts electron to become O2 minus in gas, also in gas state. Okay, so this is just the equation. Okay, now let's look at the delta H ataupun the energy change involved. As you can see, they become positive dekat situ. And this is the amount of energy absorbed. Okay, plus means the energy need to be supplied. Okay, the ions itself requires energy in order to accept the electron. Okay, okay, why is this so? Kenapa dia jadi macam ni? Kenapa dia tak negatif? Kenapa negative and then become negative lagi lah. So all the values become negative. Okay, so there's something that you need to consider. Kenapa dia become positive here? Okay. The second EA is a positive value because an electron approaches an ion with a net charge of -1. Okay, so the incoming electron, the second electron though, is strongly repelled by existing electron. So more energy is needed to overcome the repulsive forces. Okay, all right. So O accepts electron to become O minus. Okay, so it release energy. But O minus is now, okay, the repulsion in O minus is now higher. Sebab you dah tambah electron in oxygen, so basically the repulsion in the ions is now higher than before. Sebab dah ada extra electron there. And now you want to add in more electron into the ions that's already having higher repulsion dekat situ. Okay, dia menolak, dia menolak the electron tu, and then you nak masukkan the electron yang memang of course it will create more tension ataupun create more repulsion. Okay, alright, so how do we add the electron into the ion? So in order to do that, we have to supply energy. The incoming electron need to be supplied with enough energy. Kenapa? Because this electron need to overcome the repulsion in the ion itself. Okay, sesama electron tu dah ada repulsion, and then accept electron lagi, dah tinggi the repulsion, and then nak accept another one electron. So can you imagine how high the repulsion in the ion? Okay, all right. So still the electron can be added, but with the help of extra energy. Okay, so as you can see, it still can become O2 minus, but the process of the reaction will requires energy. Okay, all right. So this is the explanation, because they now overcome the repulsive force that already in the ion, the -1 ion. Okay, all right. So atoms with a low EA means it has more positive value, okay, ataupun less negative value. Low EA. Remember, EA adalah energy change. Okay, all right. So EA by right, normally EA will become negative. Tapi kalau low EA, it shows that it is less negative ataupun more positive value. It carries the same meaning. It's either less negative, the value is less negative, or more positive. Sama kan? Less negative maksudnya more positive lah. Okay. Okay, atoms with low EA tend to form cation. Atoms with a high EA having more negative value ataupun less positive value, okay, tend to form anions. Okay, so can you imagine, okay, across the period, EA increases. Okay, kita tahu kan, group 17, group 16, group 15, they tend to form an ion, betul tak? Okay, they tend to form an ion because it need to accept, they need to accept electron in order to become like noble gas, to become stable configuration, to have a stable configuration. Okay, alright, in order to do that, dia kena accept electron. Okay, alright, so dia across the period, the Z effective increases, the higher, okay, the attraction becomes stronger, right? So the higher the higher the electron affinity, okay, the higher tendency they have in order to accept electron. Okay, right. No wonder lah across the period EA tinggi dekat sini, high EA. because they tend to form an ion. And the Z effective also supports that, this explanation here, this statement here. Okay, low EA. Low EA duduk dekat mana? Group 1 and group 2. Group 1 and group 2, instead of accept electron, they prefer to remove electron. Betul tak? Cation ion, sodium. Sodium become sodium plus, barium become barium 2 plus. Okay, because why? Kenapa? Because they have low electron affinity. Dia tak suka electron. Okay, instead of accepting electron into the atom, why not remove the electron? Okay, remove the valence electron in order to become like noble gas. That explains why, okay, group 1 and group 2 having low EA. Okay, having low EA because they tend to form cation. Group 17 across the period yang more on the right hand side of the periodic table, okay, they have high EA. Okay, sebab they tend to form an ion. They become an ion kan? They tend to form an ion because kenapa? Because they have high electron affinity. Dia suka terhadap electron. Okay? Okay, so the trends in EA are not as regular. Okay, we have anomaly. Again, we have anomaly here. Okay, anomalies ni you kena take note. Okay, please be careful on anomalies. It's not as regular as those for atomic size of ionization energy. Okay, this is the general trend. Okay, normally kita ada macam ni kan, the general trend across the period, it should be increases. The EA should be increases. Down the group, the EA should be decreases. Okay, due to shielding effects. The attraction become weaker. Okay, so nak tarik the electron inside pun problem. Why? What else nak attract the electron from outside. Okay. So dekat sini dia explain. This one we have in this second point, as the atomic radius of the element decreases, the attractive forces of the nucleus increases, hence the tendency to accept electron increases. Generally, the EA value become more negative. Okay, across the period, the EA value become more negative from left to right across the period. Okay, student tahu increases tapi dia tak tahu in terms of value. So please take note on the value itself. Okay. Yes, EA increases. By increases mean it become more negative. The value become more negative. Okay, going down the group, EA decreases. Masuk EA decreases, the EA value become less positive ataupun dia become more positive. Okay. Alright. So this is the general trend that we have. However, we have anomalies. Group 15, lagi sekali yang sama group 15 dengan group 2. Okay, group 15 and group 2. Okay, and again, it's all because of the stability of electron orbital. Like, yes, the stability of the orbital. Okay, unfortunately, we do not have orbital diagram in here, but you can always draw it on your own. Okay, so that you get better understanding rather than having all this explanation. Okay, you may use the orbital diagram. You refer from the ionization energy and then you use it in electron affinity. Okay, so group 15, as you can see, group 15, supposedly across the period it should become more negative. Nampak tak? Nitrogen di suddenly positive. Okay, the positive, and then this value is not that high lah. Okay, let's look at this one. Okay, nampak problem dekat sini. So across the period, the EA should increase. Down the group, the EA should decrease. Okay, alright, nampak group 2 and group 15. Okay, tengok n is equal to 2, 3 and 4 lah. Okay, normally dekat bawah tu we are not focusing on the lower part of the periodic table. Okay, alright, so nampak tak? Supposedly it should be more negative than the carbon, but now they become more positive. Why guys? And then group 2, okay, it should be more negative than group 1. It should be more negative than group 1, tapi dia more positive than group 1. Why? Okay, so the same understanding we have for ionization energy is applied in electron affinity due to stability of the orbital. Okay, alright. Cuba tengok kat sini. EA then expected because extra electron must be paired in the partially filled orbital. Remember group 15, partially filled? Okay, nitrogen. Nitrogen, 1s, 2s, and then 2p. Okay, dia ada 7 electron, betul tak? So this is how nitrogen punya orbital diagrams looks like. Okay, so 2p is already stable. By stable means, maksud stable tu apa? Dia tak favor accept electron ataupun nak remove electron. Dia tak favor any of these two. Bila you nak paksa dia nak remove ataupun you nak add in, okay, to form from stable to become unstable, you will need extra energy. You have to force the process to happen. In order to force, you need to supply energy. That is why the value here is positive 7. Okay, that is why the value here is less negative. Okay, it is less negative. Okay, sebab from stable, if electron is added here, let's see, we use blue. Okay, katakanlah we add in electron, 1 electron there. So the whole orbital will become unstable because it is no longer half filled, it is partially filled. So this partially filled is unstable. Okay, that's why they tak favor accepts electron and also remove electron. Okay, the ionization energy become higher, the electron affinity. Okay, make sure you jangan confuse in terms of ionization energy. It become higher. Kenapa higher? Because dia dah stable. You nak remove the electron from a stable orbital will require higher energy. But in terms of electron affinity, it will become lower. Okay? Become lower sebab dia tak suka electron. Dia tak favor to accept electron. So tak favor tu the energy is become more positive. Okay? It become more positive ataupun less negative. Okay, so jangan confuse dengan dia punya trend tu, okay? Make sure that you really understand it. Yeah. Okay, and the trend for group 17 down the group generally, okay, this is not anomaly. Group 17 is normal, okay? Group 17 down the group generally become less negative. This is due to this electron affinity decrease down the group. Okay, kenapa down the group decrease? Because the atomic size become larger. Because increase in N, right? Okay, N increases. Bila N increases, the size become larger. Bila the size become larger, the attraction become weaker. Bila weaker, that means the nucleus is unable to attract. Bukan unable, dia boleh attract but not as much lah. Okay, compared to kalau N dia decrease, N sikit. Ni N dah banyak, attraction dah kurang. So nak attract the electron in the atom itself pun trouble. What else nak accept the electron from outside. Okay, so thus less attraction between incoming electron and nucleus. Okay. Okay, so that is group 15. Okay, let's look at group 2 and group 18. So as you can see, this is group 2. Nampak tak? The beryllium is positively charged. And then starting calcium, dia dah become negative. Dia dah start becoming negative value, but still it is less. Okay, it is less negative than group 1. Ni, this one. Okay. It is less negative than, for example, beryllium. Beryllium has positive value than lithium. Sepatutnya EA kena become more negative as we cross the period from left to right. Okay. Alright. So all noble gases sebelum tu, okay, generally very low EA. Okay, group 2 and 18 generally have very low EA because added electron goes into higher energy level or sub level. Okay, take for example beryllium lah, beryllium. Okay, look at the orbital diagram. So beryllium has 4 electron, 1s and 2s. Okay, dia kata dekat sini very low EA because the added electron goes into higher energy level or sub level. Okay, alright. So having 2s is already stable because not as stable as noble gas punya configuration. Okay, it's because of 2s the orbital itself is already stable because it is fulfilled. Now, bila nak accept electron, the electron need to be added. This is fulfilled already, okay? The extra electron need to be added into the 2p vacant ataupun empty orbital. So the electron will be added into this 2p orbital. And this 2p orbital is unstable because it is only partially filled. Okay, that's why they kata because added electron goes into higher energy level. So 2p is has higher energy compared to 2s. Dah lah situ higher energy, and then when the electron has been added, this orbital is unstable. Is unstable. Dia tak stable lah. Okay, that is why in order to push the electron into the system, into the orbital, the energy is needed. The energy is required. That explains why beryllium having positive EA, not negative ataupun more negative EA than group 1. Okay? All noble gases exist as monoatomic species because they are very unreactive. Okay, noble gases they exist as monoatomic because they are very unreactive and have little or no tendency to combine among themselves with other elements. Okay, kenapa all noble gases mesti nak combine pula kalau dia dah stable? Okay, the reason they combine with one another is because again to achieve the stability. Okay, they can either remove electron or accept electron, or they can also combine in order again to achieve the stability. Okay, so kalau these noble gases have already achieved the stability by being monoatomic, maksudnya single atom, kenapa perlu nak combine? Kan? Why do we need to combine? Okay. So that's why helium, neon dia tak ada, you tak pernah dengar lah that helium combine with hydrogen, helium combine with sodium, no such thing. Because helium, neon, all of these noble gases already stable. Okay? So the electron configuration of the noble gases shows that their atoms have completely filled outer S and P subshell. Okay, look at beryllium ataupun magnesium lah. So magnesium, 2s, 3s, okay, 3s. 3p, how about 3p for magnesium? It's vacant, dia kosong dekat situ. Okay, so this is even though this is stable, but the 3p is still vacant. In order to achieve the most stable form of electron configuration, they kena 3s and 3p should be fulfilled, like what we have for noble gases. Okay, so that is what it meant by atom have completely filled outer S and P subshell. Maksudnya dia punya S dia, this is for neon lah, for example, 2s and 2p. Kalau beryllium, dia 2s dia fulfill. Tapi for neon, okay, the 2p orbital is also fulfilled. So this is the most stable form of electron configuration. This is an example lah, okay, example. So same goes for all the elements in the group 18. Okay, itu maksudnya outer S and P subshells are completely filled, indicating great stability. Okay, bukan kita kata stable je, dia great stability. Okay, stability banyak, ada cara macam-macam nak capai stability, half fulfill, half fill and so on. But the most stable one ataupun having great stability is when all the orbitals are now fully filled, penuh semuanya. That is the most stable form. Okay, right. So that is why group 2A and 18 are less negative or more positive of all elements, and they have less tendency to accept extra electron, having smallest electron affinity ataupun more positive value. Again, kalau you nak masukkan elektron dekat dalam neon, for example, you kena buka the new orbital. In this case, kena buka 3s. 3s has higher energy compared to 2p. So dekat situ pun you kena masukkan, you kena supply energy. Okay, because the electron need to be added to a higher energy level ataupun higher sub level. Okay, right. So that explains why electron affinity for 2A dengan group, for group 2 and group 18 having less negative ataupun more positive EA. Okay, right. So this is what we have mentioned just now. Okay, so please take note, group 2A and group 15 and group 18. Okay, right. Okay, remember the general trend will be across the period, the EA would increase, except for group 18. Group 18 is very special. Okay, this increase in EA only applies until group 17. Guys, please take note on this. Okay, this higher EA is not applicable for group 18. Even though dia across the period, dia yang paling kanan on the periodic table, but it is not applicable to group 18. Okay, so EA will increase until group 17. So group 17 has the highest EA. Okay, has the highest EA. Yeah, ada kat sini. In any period are the halogens. Okay, alright. So let's hold on to this first. Kita kena proceed to electronegativity. Okay, and then we'll come back to that. Okay, guys, we are done with electron affinity. Now let's move on to electronegativity. But before we do that, any question, guys? Any question from the floor? Please do ask. Related to electron affinity, okay ke?
Okay.
Okay. How about others?
Okay. Okay.
So far so good Faham electron affinity
So good.
Okay, no question so far. Okay, macam hebat sangat dia tak ada explain. Apa dia?
Kenapa tak belajar untuk electron affinity, belajar unsur peralihan?
Okay. Sebab it is complicated. Okay. Remember last time we have anomalies for transition element. Okay. So for this main group element, we have few anomalies. Betul tak? Yang we have to take note. But for transition element, there are a lot of anomalies. Banyak anomalies dekat situ. Okay, alright. So what we want is to introduce to you the periodicity, the trend in the periodic table, the variation in size, electron affinity, ionization energy, and so on. Okay, yang tu kita punya target. But with few anomalies, just to highlight the few anomalies because not everything pun follow trend. In fact, in chemistry banyak sangat anomalies. Okay, tak semua ikut trend. Banyak yang ikut trend tapi not all lah. In fact, for our for the periodic table itself, the group yang paling banyak tak ikut the trend would be from the D block element ataupun from the transition element. Okay, so last time we used to have that in the slides, but we have removed it, okay, because there's a lot of anomalies. Kita kata in terms of orbital diagram, normally based on the stability of the orbital. Sometimes it's not based on the stability of the orbital. Okay, dia jadi macam tu. Dia tak ikut trend. Okay, so in fact in the transition element tu masih research is still ongoing tau. Dia keep on adding elements kan, new elements in the periodic table. Okay, that's why you kena update you guys punya what do we call that periodic table. Sentiasa ada elemen yang baru, tapi it does not concern us because our focus is more on the main group element, group 1, group 2, 13 until 18. Okay, kita just sikit-sikit lah yang you tahu, chromium, copper kan. Sebenarnya we have more than that. Kita ada lebih daripada 5 kot anomalies in transition element itself. Okay, that's why our focus is not on the terlampau banyak sangat anomalies sampai kita nanti susah nak evaluate student. After all, kita foundation kan, we want to introduce the concept first. If you want to know in detail, that means you have to further in chemistry or later on physics ke apa. Okay? Hope that answers your question lah. Okay? So ini pun dah boleh tahan. Apatah lagi nak tambah dengan transition element. Okay? Alright, so let's move on to electronegativity. I assume there is no question. Okay? Further question from you guys. Okay, kita proceed with electronegativity. Okay? Electronegativity means electron juga, electron, and then negativity. We know that electron, it is negatively charged. Okay, so again, this is also kesukaan terhadap electron. Okay, preference towards electron, but the definition is slightly different than the electronegativity. But the concept is almost the same. Kesukaan terhadap electron. Okay, so in proper definition of electronegativity, it means electronegativity of an element is the measure, okay, the measurement of the ability of an atom to attract a bonding pairs of electron in covalent bond. Okay, remember electron affinity just now is the energy change, but electronegativity is the ability of the atom itself to attract a bonding pair of electron in covalent bond. So this electronegativity applies in covalent bond. Okay, dia lebih specific. So this electronegativity will be applied in topic 3 later. Okay, alright. For example, HCl. Okay, in covalent bond. Okay, during bonding. Okay, HCl. We know that Cl, they form what we call that hydrogen chloride covalent bond kan, so they share electron. Okay, so Cl, so basically they share, katakanlah. Okay, alright, so by right, kalau dah kata share, you should share. Okay, these both atoms should share the electron equally, sepatutnya. Tapi due to different electronegativity, so hydrogen and chlorine, they both have different electronegativity. Okay, chlorine has chlorine is more electronegative than hydrogen. Bila chlorine is more electronegative than hydrogen, okay, it is powerful enough to attract these two electrons towards itself. Apa tak? Dia still sharing tapi dia bias dekat situ. The electron is not shared equally. Instead, the electron, the bonding electron tu is pulled towards chlorine. Because why? Because chlorine has higher electronegativity compared to hydrogen. Kenapa has higher electronegativity? Sama lah kisah across the period. Okay, because of the Z effective. Remember, Z effective is the power of the nucleus, okay, to attract the electron. It is powerful enough not only to attract the electron in the atom, okay, dia boleh tarik the electron from outside. Okay, inilah outside. Ni maksudnya outside lah ni. This is not in the system. Dia dalam sistem, tapi this is special because it is involved in the bonding. So instead of they share equally, dia macam ni. dia lebih kepada so ni dekat sini. Still sharing ni still sharing. So tapi due to electronegativity difference, both electron are attracted to the most electronegative atom in the covalent bond. Okay, all right. So the concept of electronegativity is described as the more inclined an atom is to gain electron, the more likely the atom will pull electron toward itself. Maksudnya dia suka dekat electron. Okay, across a period, the elements that prefers to accept electrons are the one dekat most right of periodic table, except for group 18. Okay, except for group 18. Okay, trend. How about the trend? Sama saja, the trend in electronegativity are similar to those for EA. Sama, okay? Alright, so down the group, you have to mention in terms of quantum number increases, shielding effect increases, distance become larger, okay? Therefore, the strength to attract electron decreases. So, maksudnya lower electronegativity. As for across the period, is due to Z effective. Okay, so across the period, Z effective increases and then the size becomes smaller, attraction becomes stronger. Not only it can attract the electron inside, it can also attract the electron from outside. Okay, so yang ni lah benda yang sama dekat sini. Alright, so this is just to show you across the period, it is increases, down the group it decreases. Nampak? Okay, cuba tengok group 2 lah. Kita try period 2, lithium. Lithium having electronegativity equal to 1 and then beryllium 1.5 and then boron 2.0 kan? Nampak tak? Increasing. Okay, the electronegativity values increases. Okay, down the group, dia decreases. Okay, right. So those are the values. Yeah, ini pun contoh sama nak tunjukkan across the period. As you can see, increases. So fluorine is the most electronegative. Okay, group 17, most of them are the most electronegative atom in the periodic table. And fluorine being the most, dalam group 17 tu kan ada 5 adik-beradik kan. So antara the most electronegative would be fluorine. Okay, these 3 FON are the most, are the 3 most electronegative atom in the periodic table. And fluorine is the king lah. The king ikut ranking fluorine and then oxygen, nitrogen. This is the most electronegative, followed by oxygen and then nitrogen. Okay, based on the value you can see. Okay. Alright, okay, we are done with we are done with topic 2, guys. Basically, the content has been delivered, okay, except for the checkpoint. Okay, so please complete the checkpoint. Maybe you can try out this checkpoint 21 together. Consider the following elements from the periodic table. Okay, let's apply what we have learned for electronegativity. Okay, you have to arrange in order of increasing electronegativity's value. Okay, as you can see, the Z is not given, so it is, the Z should be given lah. If you are not supposed to refer the periodic table, by right, the Z should be given. Okay, alright, so you may refer your periodic table or you may use the Z value from the periodic table. Okay, alright, to keep it short, kita nak direct itu terus, okay. So aluminium come from N is equal to 3. Calcium, okay, dah boleh hafal lah. Yang mana yang group 1, group 2 ni dah boleh hafal N is equal to 4. Boron, carbon and fluorine, these 3 come from N is equal to 2. Okay, so we have the trend already just now. Dia kena increasing electronegativity. So from the lowest, okay, from the element having the lowest electronegativity going up, okay, to the highest electronegativity. So the lowest will be, guys,
Calcium.
Okay, sebab N is equal to 4 kan, okay, the size larger, the attraction is weaker and so on lah, shielding effect is larger also. followed by
Aluminium.
yeah, alright. So now, okay, this is in terms of down the group, N4 and 3. Okay, so Ca, carbon and fluorine, they are all come from the same period. If they come from the same period, that means we have to consider the Z effective. Okay, so across the period, Z effective increases. So fluorine is the most right elements in the periodic table, kan? So by right, okay, boron come from group 13. Okay, buat kat sini lah. Boron, carbon and fluorine. So boron come from group 13. Carbon come from group 14. Fluorine comes from group 17. So boron having a Z effective is equal to positive 3, carbon positive 4, fluorine positive 7. Okay, so the Z effective increases. So by right, BCF lah. Macam ni lah. Okay, B, C. Malas betul buat macam tu. B, C, F. Okay, don't forget the arrow and then increasing electronegativity. Okay. Okay, alright. So this is the only checkpoint for electronegativity. Okay, so we have other checkpoint from EA and ionization energy. Okay, that one we will discuss next week. So please bear in mind, definitely we are going to have additional class for our lecture. Okay, sebab kita dah jauh terlajak daripada track kita ni. Supposedly this week we should be starting the topic 3. Tapi obviously baru nak habis topik 2. Okay, so next week probably there will be an additional class ataupun lecture. So whatever it is, I will inform later. Okay, alright, okay, just nice. Okay, that's all for today's lecture. Any question, guys?
Madam.
You?
Nak tanya, tapi dia bukan dalam bab electron affinity lah. Macam gini, masa saya buat latihan tu, saya ada nampak macam satu kelemahan lah, macam saya tak faham. Okay, kan dalam kalau kita nak tentukan macam Z efficient tu kan formula dia adalah proton numbers tu tolak dengan core electron. Okay, kalau kita dah tahu atom tu apa, contohnya macam atom tu kalsium kan, so kita dah tahu dia punya proton dia tu 20 dan kita tahu electron valence dia tu memang ada 2 kan. So 20 tolak 2 which is core electron tu adalah 18 lah. So macam mana kalau contohnya dia bagi mungkin dia just bagi Z efficient tu contohnya positif 13. Okay, positif 13 kan. So how do we want to decide dia punya core electron tu, macam mana kita nak cari? Kita tak tahu atom tu atom apa, dia just bagi Z efficient dia nombor something lah macam 13 contohnya. So how do we decide the core electron in order to nak tahu nilai proton dia yang sebenar tu?
Okay, it depends on the question lah. Depends on the information given in the question. Okay, and then dia depends on the question yang dia nak tanya. Okay, kalau dia dah bagi positive 13 tu, is it referring to the Z ataupun dia refer kepada Z effective? Because these two are two different things. Z adalah number of proton dekat dalam nucleus, but Z effective is the attraction, okay, the charge that is felt by the valence. Okay, so nak kena tahu dia bagi Z ke dia bagi Z efektif? Dia bagi nukleus punya charge ataupun dia bagi Z efektif? Okay, alright. Lagi satu, ya.
Dia bagi nukleus punya charge, madam.
So maksudnya itu adalah Z lah. Okay, alright. Dia depends on the question. Dia tanya question apa? Kalau yang sampai nak kena tahu core electron tu, dia mesti ada bagi extra information dekat situ. Kalau tak, it's not doable. Okay, cuma you kena extra information tu make sure that you know how to use it lah. Okay, so saya nak kena tengok, nak kena tahu what is the soalan, the following question tu, and then what are the information given. So by right, all the information need to be given. If not, it's not doable. Dia masalah lah. Macam you cakap, macam mana kita nak tahu core electron? Okay, make sure that you have all the information, bagi kat saya. Okay, WhatsApp me all the question. And then let me read the question first and then saya boleh conclude. Kalau tak cukup, that means soalan tu tak don't have enough information and it requires extra information. That means you problem lah. Dalam exam dia akan jadi problem lah. So it should not be like that. Okay, dia kena bagi extra information. Tapi saya tak boleh judge macam tu, saya kena baca dulu soalan tu. Okay?
Alright, thank you, madam.
Okay, maybe you can PM me. Alright, I think that's all. Okay, so it's 10:58. Thank you everyone for your attention and we'll see you during tutorial. Okay? Alright, assalamualaikum and bye.
Thank you, madam.
Thank you.
Thank you, madam.
Thank you, madam.
Okay.
Thank you, madam.
Right.